Nice to see you all once again in this online physics class for standard 9. So now we are doing the exercise part and we have taken up the numericals first, right? So today also I'll be solving two sums from textbook page number 144. In the previous class also I've solved two sums, and today's class also I'll be doing two sums. So these two sums are given in your textbook page number 144. I've marked it as question number 3 because it's a continuity. In the previous class I've solved two sums, no? So today I'll be solving two questions. So I've marked it as question number 3 and question number 4. Remember, these are from your textbook page number 144. Let's start solving now. Look at the question here. A stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. See here, they have given the height of the tower as 19.6 meter, and they have said a stone is dropped down from the top of the tower whose height is 19.6 meter. They want you to calculate the final velocity before touching the ground. See this, before touching the ground. Okay, I'll talk about that later. So what is the thing that you have to calculate here? You have to calculate the final velocity. Final velocity is always marked with the letter V. So height h is given. Final velocity has to be calculated. Initial velocity is obviously 0. So we have to apply the equation of motion. Which equation will be choosing here? V square is equal to u square plus 2as, because we have to calculate final velocity V. But the letters A and S should be replaced with G and H. S is the distance. Here distance, it's noted with the word height. And A should be replaced with G, because we are talking about the object that are thrown towards the ground from a height. Okay, so we know that value of small g on the surface of the earth is 9.8 meter per second square. So what are the terms given here? Initial velocity is 0, which is represented with the letter u. Final velocity is to be calculated, V. Acceleration due to gravity on the surface of the earth, that is small g, is 9.8 meter per second square. Height is 19.6 meters. So substituting all these values in this equation, V square is equal to u square plus 2gh. I have already told you why we are writing this equation of motion, which is normally written as V square is equal to u square plus 2as, as V square is equal to u square plus 2gh. When we are talking about objects falling towards the earth's surface or moving away from the earth's surface, in that case it should be replaced with letter G. And one more keyword, dropped from a height and all is given. Okay, so when you substitute these numbers, 0 in the place of u, 9.8 in the place of g, 19.6 in the place of h in the equation, v square is equal to u square plus 2gh, it becomes 0 square will be 0. 2 into 9.8 is 19.6, because 98 multiplied by 2 will give you 196. It is 9.8. So one decimal point you have to keep there. So it becomes 19.6. And already height is given as 19.6. V square is equal to, that 0 square is 0. So we will not consider that. 2 into 9.8, we got it as 19.6. Already h is 19.6. So V square is 19.6 into 19.6. We need to calculate V. So this 19.6 into 19.6 can be written as 19.6 whole square. Yes. 4 square is 16. Square root of 16 is 4. Similarly, 19.6 into 19.6 is 19.6 the whole square. V square is 19.6 the whole square, means V will be 19.6. You can cut the index number on both sides. Instead of multiplying this 19.6 with 19.6 and finding the square root, this is the easiest method. Directly you have to apply. So when we do that, we get the value of V as 19.6 meter per second. Therefore, the question is answered here. The velocity of the stone just before hitting the ground will be 19.6 meter. I told you, just before hitting the ground is just to make you think further. Nothing. The question is talking about finding the value of the final velocity only. Understood? Okay, let's move on to the next question. And one more thing I want to tell you. After you watch this session, please watch it twice, thrice, understand what is told, open your textbook, take out the sums, try to solve on your own and see, recollect, recall what you have done. If there are mistakes, play once again and see where you have done the mistake. Then again you practice, never it goes wrong. You remember one thing, practice makes a man perfect. So nothing is difficult. Keep practicing. Again and again you have to practice. Okay? The sum is very simple. If you are thorough with the formulas that have to be applied here, then everything will fall at its place. Now next question. It's also very simple, but sounds little tricky, twisting and all. Nothing. Just see this question. A stone is thrown vertically upward with an initial velocity of 40 meter per second. Taking g as 10 meter per second square, find the maximum height reached by the stone. And then, what is the distance, displacement and the total distance covered by the stone when it falls back to the ground? See, a stone is thrown vertically upward. It is thrown upward. You are throwing it upward. Okay? With an initial velocity of 40 meter per second. What is the letter that we use for representing initial velocity? U. I have not mentioned here, it is understood. Initial velocity is normally represented with the letter U, which is 40 meter per second. And final velocity, it has reached back to the ground because they are asking you to calculate the total distance. Okay, so that should be assumed as 0 meter per second. 0 means you need not talk about the unit also. Then acceleration due to gravity, they have told that it should be taken as 10 meter per second square. First you have to calculate the maximum height reached by the ground. So again, by taking this equation, because we have the value of V, U, G, you have to find the maximum height, so we have to apply this equation. I have told you why we are using these letters G and H here. It was repeatedly said. So substituting the value of V, U, G and H in this equation, V square is equal to U square plus 2GH. V square is 0 square, U square is 40 square, 2, G is taken as minus 10. G value is given as 10 meter per second square. We are taking it as minus 10 because we are going to calculate the maximum height reached by the object when it is thrown upward. When the object is moving upward, acceleration due to gravity should always be taken as a negative value because it is in the opposite direction. When it is towards the ground, it is positive, G is positive. When it is above the ground surface, it is always negative, remember that. So G value is taken as minus 10 here. Minus, I said, why? Because it's talking about the object which is moving upward. And height we have to calculate. 40 square is 1600, 40 into 40. 2 into minus 10 is minus 20. So plus into minus 20 will give you minus 20. H is there. So we get this 0 square as 0. 40 square is 1600. 2 into minus 10 is minus 20. Plus into minus 20 is minus 20H. Now let's take this minus 20H to the other side. It becomes plus 20H, which is equal to 1600. So what will be H? H will be 1600 divided by 20. 1010 you can cut. Then you will have 160 divided by 2. What is 160 divided by 2? 80. So maximum height reached by the stone, height when it is thrown upward, maximum height it reaches would be equal to 80 meters. Okay, so this part we have calculated the maximum height reached by the stone as 80 meters. What is left in the question? You have to calculate the displacement and the total distance traveled by the object after it falls back on the ground. Total distance, right? Total distance traveled. So maximum height we have calculated as 80 meters. Displacement is what? It is the shortest distance between your initial and final points. Now the initial and final point remains the same. So what's the initial point? From the ground it is thrown upward, right? Then final point is again reaching the ground. So when the initial and final points remain the same, displacement is always 0. So the stone is thrown up from the ground and after reaching the maximum height, it falls back to the ground. As the final position of the stone coincides with the initial position of the stone, the net displacement of the stone is 0. When we were talking about the chapter motion, in that it was clearly explained about displacement. It is the shortest distance between your initial and final points. When the initial and final points remain the same, displacement is always 0. Now, what is the total distance covered by the object after it reaches the ground? The object is thrown up. Okay. So they told us to calculate the maximum height that the stone would reach. We have calculated it as 80 meters. When the stone is reaching a height of 80 meters, it is again falling back to the ground. That means what? Again it will travel a distance of 80 meters towards the ground. So what's the total distance traveled? Maximum height it reached, and then from there on reaching the ground. From ground to the maximum height, if it is 80 meters, then from there to the ground, that means from the ground to a point above the ground, the height is 80 meter, means from that point again back to the ground is again 80 meters. So the total distance would be 80 plus 80, which is equal to 160 meters. Therefore, the distance covered by the stone in reaching the maximum height is 80 meters. The stone will cover the same distance of 80 meter in coming back to the ground. So the total distance covered by the stone is 80 meter from ground to a point above that height, and from that point again below to the ground will also be the same distance, which is equal to 80 meter. So total would be 160 meter. Okay, so with this the sum gets over. So we have completed 2 sums. So you practice these 2 sums. Okay, meet you soon in the next class. Till then, take care. Bye.